Hi, this is Hilal. In this video on Mathematical Economics series, we will solve a numerical on finding the income model using Cramer's rule. So the question is, solve the following income model using Cramer's rule. That is, y is equal to c plus I0 plus G0, where c is the consumption, I0 is the autonomous investment, and G0 is the government expenditure. And c, that is consumption, is a function of alpha plus beta times y minus t, where y is the income and t is the tax rate. Similarly, this t is equal to gamma plus delta y. Here this alpha is greater than 0 and the value of beta here, beta, which is the marginal propensity to consume, the value of this lies between 0 and 1. Similarly, this gamma is greater than 0 and this delta lies between 0 and 1. So we have to solve this using Cramer's rule. Now first of all, we will see what are the endogenous variables here and what are the exogenous variables. Now endogenous variables are those variables whose values are found within the system, that is, whose value is determined within the model or system. That is, endogenous or endogenous variables are those variables whose value is found within the model. Here the endogenous variable is this income. Income is the endogenous variable here. Similarly, this consumption is endogenous variable, and this taxation, that is t, this tax rate, it is also the endogenous variable, because these values are found within the model. And the exogenous variables here are exogenous variables are that are this autonomous investment. This is the exogenous variable. Similarly, this government expenditure, this is also exogenous variable, because these two variables are superimposed in this model. Or we have seen the difference between endogenous variables and exogenous variables in earlier video. Now we will solve this for Cramer's rule. First of all, we will make sure that the endogenous variables are on the left hand side, that is, they are on LHS, and the exogenous variables are on RHS. So we will make sure to take the endogenous variables on the left side and exogenous variables on right side. Now from this equation, this y is the endogenous variable, this consumption is also endogenous variable. So the equation first can be written as y minus c is equal to I0 plus G0. Now in the second equation, this c is the endogenous variable, so I will write c here, that is c. Now here y is the endogenous variable and t is also endogenous variable. Now we will transpose these terms on the LHS. Now this beta times y will become minus beta y, and since this is minus beta t here, when transposed to LHS, this will become plus beta t, that is plus beta t, that is equal to alpha here. Similarly, here we will transpose the endogenous variables on LHS. Here this is t, we will transpose this endogenous variable on LHS, that is minus delta y is equal to gamma. Now we will write this equation in order. That is, we will write the y's first, then the c's, and then the t's. That is, we can write this model like this. That is, here it is y minus c is equal to I0 plus G0. For the sake of simplicity, we will write these equations in order. Now in this, we have this minus beta y, and then we have to write the c. Here it is c plus c and plus beta t is equal to alpha. Similarly, here no c is involved. Now we will write this minus delta y plus this t is equal to gamma. Now as we know in the CRAMER'S rule, first we have to transform these system of equations in matrix form. That is, we have to make them express those equations in matrix form. That is, matrix form. Like the rule is, we write the coefficient matrix, multiply this with the solution vector, that is a x is equal to b, where b is the vector of constant terms. Here the constant terms are these which are on the RHS side, which are also exogenous variables. So this b will be the vector of exogenous variables. Now I will first we have to make the this matrix, that is the coefficient matrix. So I will write here. Now the coefficient matrix is, first we will write the coefficients of the y's. That is, here the coefficient of y is 1, here the coefficient of y is minus beta, and here the coefficient of y is minus delta. Similarly, then we have to find the coefficients of c's. Here the coefficient of c is -1, so I will write this with another color. Similarly, here the coefficient of c is 1, so I will write 1. Similarly, here no c is involved, so the coefficient was here 0. Now similarly, we have to find the coefficients of the third term. Here the coefficient of t is, because no t is involved, so the coefficient of t is here 0. Here the coefficient of t is beta, so I will write beta, and here the coefficient of t is 1. So this is our coefficient matrix. Similarly, we have to multiply this with the solution vector. Now our solution vector will be y, c, and t. That is the vector of endogenous variables. That is equal to this b. b is the vector of constant terms. Here our vector of constant terms is I0 plus G0. Here it is here it is alpha, and here it is gamma. So first step was to express these system of linear equations in matrix form. After that, this is A, as we know this is the coefficient matrix. We have to find the determinant of this coefficient matrix. That is, we will find the determinant of this A, that is A is equal to, now here it is 1, so I will write 1. should I use the proper color to make you understand? That is 1. It is multiplied by this. Now delete mentally the row and the column in which it appears and take determinant of the remaining elements. That is 1 0, and here it is beta 1. So then we take the minus sign, minus, and here it is minus 1, because first is plus then it is minus, as we have seen in the law of cofactors. So this is minus 1, and take the determinant of, that is delete mentally the row and the column in which this element appears and take determinant of the remaining elements. Here the remaining elements are minus beta and gamma, sorry, it is delta, so I will write minus beta and minus delta, and here it is beta and 1, so I will write beta and 1, then plus the third element, that is 0, multiplied by, now mentally delete the row and the column in which this 0 appears and take the determinant of the remaining elements. Now the remaining elements are here also minus beta, minus delta, and 1 and 0, 1 and 0. Now I don't need the colors here, this was only for the sake of understanding, so I will multiply them. Now this will become 1. Now this is 1 into 1, that is 1, minus beta into 0 is 0. Now this minus minus is plus 1. Now here this will become minus beta into 1 is minus beta. Now minus and there is also minus, so minus minus is plus. This will become plus beta delta plus 0. This is 0 times this determinant is also 0, so I will not write this here. So this is equal to, that is 1 into 1 is 1, that here it is minus beta, here it is minus beta, then it is plus beta, this beta and delta, beta and, so I will write it here. So this is equal to 1 minus, now factor out this beta, so we are with 1 minus delta, which is not equal to 0. If it was, why it is not equal to 0? Because the value of beta lies between 0 and 1, so this is not here 0, because 1 minus 0, it is a non-zero number, so this will not be equal to 0. So I will write here since 0 lies beta lies between 0 and 1, and similarly this delta lies between 0 and 1. Here we see, so I will write here delta lies between 0 and 1. So this is not possible that these this term will become 1 in any case. So here the determinant is greater than 0. Now we have to solve for y. Now to solve for the y, first of all, that is, we have to form a new matrix, as we have seen in the earlier video. Now the new matrix is formed, the first matrix is formed by replacing the first column of the coefficient matrix with the column of the constant terms. That is, to solve for y, replace first column of this coefficient matrix with the vector of constant terms, that is, and form a new matrix, and form a new matrix. So our new matrix will be like, that is A11, that is A1. This is the new matrix which is formed by, so I will write here, which is formed by replacing the first column of the coefficient matrix with the column of the constant terms, which is the vector solution. So our new matrix is I0 plus G0 alpha and gamma. Now these two will remain the same, so I will use the proper color for the sake of understanding. So this is -1 1 0, and this is 0 beta and 1, 0 beta and 1. Now should I see? Yes, it is. So I will write here. Now we have to take the determinant of this. Take the determinant of this matrix, that is, sorry, here it is A11. Now we have to take, this is A11 only. Now its determinant is A1. That is we take the determinant as we have seen in this portion. So I will use the same method here. First I take the first element, that is I0 plus G0, and multiply this. So I mentally delete the row and the column in which it appears, and take the determinant of the remaining elements. The remaining elements are 1 0 beta 1. Then we have the minus sign, and here it is also minus, so I will write this -1. Now mentally delete the row and the column in which it appears, and take mentally delete the row and the column, and take determinant of the remaining elements. Now the remaining elements are here alpha and this gamma, so I will write alpha, gamma, and beta and 1, so I will write beta 1. Then we have plus this 0, so I will use the proper sign here, sorry, proper color here. Now mentally delete the row and this row and the column in which it appears, and take the determinant of the remaining elements. Now the remaining elements are alpha and gamma, alpha, gamma, and 1 0 1 0. Now we will solve this. We will solve this quickly. So this is I0 plus G0, so I will write here it is I0 plus G0, so I will write this in brackets. Now multiply 1 1s are 1 minus beta into 0, so that is 0, 1 minus 0, that is 1 here. Now this will become minus minus is plus. Here alpha into 1 is alpha, minus gamma into beta, that is gamma into beta here. Similarly here it is plus. Now 0 times the determinant is 0, so I will not write this, because this will become 0 into anything is also 0. Now that is our, so I will write this like, first I will write alpha minus gamma beta, that is, or I will write this as it is, that is I0 plus G0 plus alpha minus this gamma beta. So this is our the determinant of the new matrix which we have formed by replacing the first column of the coefficient matrix with the column of the exogenous variables or the vector of constant terms. Now using Cramer's rule, so using Cramer's rule, now our y is equal to equilibrium, y will be equal to, that is equal to this new determinant, that is a1 divided by the original determinant, that is a. Now solving this will give us, now this is I0 plus G0 plus alpha minus gamma beta divided by the original determinant, that is 1 minus beta plus this beta, sorry, it is 1 minus beta and 1 minus delta. So this is our equilibrium level of income. Similarly, we have to find this C. So we will use a similar method here, that to solve for C, that is to solve for C, replace. Now first we replace the first column. In this case we have to replace the second column, that is replace second column of coefficient matrix with the vector of constant terms and form a new matrix, that is A2. So this is A2 is equal to, now we have to make the new matrix. Now in the new matrix, that is A2, which is formed by replacing the second row of the coefficient matrix with the second column of the coefficient matrix with the column of constant terms. So our new matrix will be, that is 1 minus beta gamma minus delta, that is 1 minus beta and minus delta. Now we have to replace this by this constant of column of constant terms, that is I0 plus G0 alpha and gamma. Similarly, our third will be the same, that is 0 beta 1. So I will write here 0, I will write it here 0 beta and 1. Now we have to take the determinant of this A2, this new matrix, that is I will write it here because of the lack of the space here. So the determinant of this will be equal to, that is determinant of A2 is equal to, that is we write the first this first number. So I will use here also proper sign, proper color for the sake of understanding. Now this one, and we mentally delete the row and the column in which it appears and take determinant of the remaining elements. Now the remaining elements are here: alpha, gamma, that is alpha, this gamma, now beta and 1. For this I will use this beta and 1. Then we have minus, that is minus. Here is I0 plus G0, so I will write I0 plus G0 and multiply this. Now mentally delete the row and the column in which it appears and take determinant of the remaining elements. The remaining elements are minus beta and gamma. So where is my another marker? That is here. So minus beta and minus gamma, minus beta minus gamma, and this beta, beta and 1. So I will write here this beta and 1. So it is here beta plus this 0 plus 0. Now mentally delete the row and the column in which it appears and take the determinant of the remaining elements, that is minus beta minus delta and alpha gamma. So I will write here alpha and gamma. Now solve this also. So this video is gone a bit lengthy, but bear with me, you will understand it. Now here it is 1, so I will write 1. Now multiply alpha into 1, that is alpha. Here it is alpha minus beta, this beta gamma. So I will write here alpha minus beta gamma, and this is beta gamma over. Now here it is minus, here it is I0 plus G0, this is in this term, and this is multiplied, this is minus beta into 1, that is here minus beta. Now minus minus is plus here, so this will become plus beta gamma, that is delta, plus 0 times this is equal to 0, so I will write here 0. Now further solving this is alpha minus beta gamma, alpha minus beta gamma. Now this will become, here it is I0, here it is I0 plus G0, this is multiplied with this. So first we will multiply this I0 with this whole term, so I will write this minus as it is. Now I0 into minus beta, that is minus beta I0. Now here it is plus. Now I0 plus beta I0 times beta delta plus, now we will multiply with this, with these two terms, that is this is here minus beta G0, that is minus beta G0, and here it is plus beta delta G0, beta delta G0. Now further solving this will become, here it is beta I0, so we will take it out here. So here it is alpha minus beta gamma, here it is alpha minus beta gamma. Now here this will become minus into minus is plus beta I0. Now this is minus beta I0 delta. Now this is minus into minus is plus beta G0. Now this is minus beta delta and G0. Now what will we do here? Here it is minus, sorry, here it is alpha, so I will write this alpha. Now here we can see this is minus beta gamma. Now we will factor out beta I0 here, that is plus beta I0. Now we are with this 1 minus delta, that is 1 minus delta. Similarly here we will take this G0 and B out, G0 and beta out, that is this term. Here it is also B0, that is G0 and beta, so we are with 1 minus delta. So this is from the mathematics quadratic equation, how to take factors out. Now this will become here alpha minus beta gamma, alpha minus beta gamma, plus here we have this beta, here we have also this beta, so I will factor this also, so I will write beta. Here it is 1 minus here it is 1 I0 plus G0, that is we will factor this out, 1 minus delta and 1 minus delta, that is when factored this out, this will become, or I will factor this out, that is 1 minus delta first. Now we are with this beta I0, that is this beta I0 plus this beta I0 plus this beta G0. So further solving this, alpha minus beta gamma plus 1 minus delta, and here we will factor this beta also, that is I0 plus G0. So this is our the determinant of A2. Now using CRAMER'S rule here also we get C dash, that is equilibrium consumption, is equal to the new determinant which we have calculated, A2, divided by the original determinant, that is A. Now our new determinant is this term, that is alpha minus beta this gamma plus 1 minus delta plus beta I0 plus G0. We divide this by the original determinant, which that is 1 minus beta, 1 minus beta, 1 minus delta. So this is our equilibrium consumption. Similarly we have to find the equilibrium taxation, that is the value of T. For this we use the same method, ditto the same method. Only one thing is we have to replace the third column with the column of constant terms. So I will not write this, I will cut it short here. So solve for T, that is our new determinant will be, our new matrix will be, that is A3 is equal to, so we have to replace this third element here. So I will not use the colors because of lack of this space here and time also. So I will write 1 minus beta minus delta, 1 minus beta minus delta, minus 1 1 0, and I will replace this by the vector of constant terms, which is the endogenous variable column, this column, that is I0 plus G0. Here it is alpha and here it is gamma. Now I have to take the determinant of this also, that is A3 is equal to, that is I will write this 1 and take determinant of the remaining elements in which it appears, that is determinant of this remaining elements 1 0 alpha and this gamma. Yes, this is gamma here. Similarly it is minus, first is the minus from the law of the cofactors, and here it is also minus 1. So I will now mentally delete the row and the column in which it appears. Now take the determinant of the remaining elements, that is minus beta minus delta, this alpha and delta here. Sorry, it is gamma here. This is gamma. Similarly, plus, so I will write here this last element I0 plus G0, multiply this. Now mentally delete the row and the column in which it appears and take the determinant of the remaining elements, that is minus beta minus delta, minus beta minus delta, and 1 and 0. Now solving this will give us, that is here, this is 1 multiply this 1 into this is the gamma here, so I will write here 1 into gamma is gamma, minus 0 into alpha, that is 0, so it is here gamma only. Now minus is here, plus, so I will write plus 1. Now this is minus beta into gamma, so I will write minus beta into gamma, Now this minus and this minus will become plus, because minus of and the this multiplication and this minus is also, so this will minus will become plus. So this is here plus delta alpha. Now we have this I0 plus G0, it is multiplied with this beta into 0 is 0, minus beta into 0 minus, and this minus will become plus, so this is plus delta. So so this will become, this is gamma. Now this is minus beta gamma plus delta alpha plus this delta and this I0 plus G0. I hope I have not made any mistake till now. If there is, I am really excuse for that. I really apologize if there is some mistake up to this point of time. Now our equilibrium level of taxation, that is T dash, is equal to the determinant of the remaining matrix, that is determinant of the new matrix, that is A3 divided by A. So this is the CRAMER'S rule here. We take the new matrix which we form by replacing the relevant column with the constant term column of constant terms. So matrix formula is this, that is the CRAMER'S formula here. Now our A3 is here, that is gamma minus beta gamma plus alpha, that is delta alpha plus alpha, this is delta. I am not getting this now because my back is paining. Now this is this delta which we have calculated somewhere, this the determinant of the ordinal matrix, that is here 1 minus beta 1 minus lambda. So this is the matrix. This is the CRAMER'S rule used in solving a system of linear equations. So one thing is to be remembered here. First of all, we have to separate the endogenous variables from the exogenous variables. That is very important in solving a system of linear equations. Here we have the income determination model, and we have used the CRAMER'S rule to express these system of linear equations first in the matrix form, and then subsequently we have deleted the relevant row, relevant column. Now here if we have to find the value of this y, we delete the first column and replace it with the column of constant terms, then form the new matrix. Similarly, to find the value of this c, we delete the second column. We replace the second column with the column of exogenous variables, that is the column of vector solutions. Similarly, to find the value of this t, we replace the last column with this column, that is, I repeat here, finding the value of first element here, we replace this column. Finding the value of this second element, we replace the second column, and finding the value of the third element, we replace this third column. So this was all about this matrix. If you really like this, please subscribe on the YouTube. Our channel is Econ Maths.